Hello engineers, and welcome to this video tutorial on function generators. We're going to learn about and how to use the BK Precision 4017A 10 megahertz sweep function generator, but we will not really use the sweep features. Today we're only going to learn about the function generator features. We use function generators to create voltage waveforms that are often used to drive inputs of electric circuits. There's a power button here on the panel with the red word power above. We turn it on, it comes up very quickly. You can see I have an oscilloscope mounted above, and there's a circuit I'll show you in a moment that's being driven, and we're looking at a waveform. Now we connect an output cable really to this one of three connectors labeled output. These other two we're not using. We just have one connector that's labeled output. That's the one of interest. It allows us to send a signal out to a circuit if we wish. Let's take a look at it. These are BNC connectors, and BNC, we don't worry about the meaning of that. It's got a complicated historical background, but we see that it has a shielded, there's a gold center conductor as shown here, and it's wrapped around with a shield. This is a coaxial cable, and the idea is this is the ground and the center conductor is the signal, and that allows us to shield and keep out electric noise so that we'll have a quiet signal overall. So remember that we have these little notches or slots, and we line up to the nub or like a nipple here on the connector. Line that up, push it in gently, and turn clockwise until it locks, and now we have an output. And often on the other end of such a cable we will have either alligator clips or easy hooks as they're called. And so I have a circuit shown here that I connected to. It was out of your view. It's just a simple RC circuit with a filter circuit with a resistor and a capacitor, and you can see that I'm using the easy hooks on the other end of the function generator cable. So I have the other end of that cable is this red connector you see here, and that's connecting that center conductor or the signal directly to the input of the circuit, and then the ground, it happens to be the lower black clip. And you can also see I've got two oscilloscope probes hooked onto this circuit too, and we'll be viewing part of that up above with the oscilloscope display. So we can select one of three possible waveforms with a function generator. With this one, you see we have the sinusoid shown in the display above, and at a certain frequency that we'll come to in a moment. But now we can select also what's called a square wave. You see that, and or a triangle wave. Let's come back to the sinusoid. The frequency is set by one of these range buttons pushed in or out, and a combination of the coarse and fine frequency adjustments. You see right now we're reading about 1,000 hertz or 1 kilohertz, pretty close. And there's a little red dot on the display that says hertz. Let's just ignore this gate signal that's flashing. We don't need to know about that. So for the moment I have the 10K range button pushed in, and I have selected a value that gives me about 1,000 hertz. If I push this up to push in the 100K, now we see that the signal the frequency is much higher, the waveforms are compressed, and now on the display down here we see the red dot by the kilohertz. So now we would read this 9.99 kilohertz. Let's come back to the 10K range. And so if I want to adjust the frequency, you can see the display changing, coarse and fine. That's how that works. So we'll just leave it somewhere near 1,000 or so. Now how about the amplitude, or the height of the waveform, called the amplitude? That's controlled by the output level knob shown here and a button labeled -20 dB. That's electrical engineering term for adding a multiplying factor. So the combination of these two. So if I want to increase and decrease my amplitude, I can use really what's kind of like a fine adjustment of the output level. But I also have the ability to go coarse and fine, big and small you might say. So when I push this multiplier in, I have the small signal, but if I let it come out, now you see on the display that we got a very large signal, and the output knob controls in either case. Let's come back to the smaller signals, which is what we're using here. The button is pushed in. Now let's come to the duty cycle, an interesting topic, and we can best see what is the meaning of duty cycle by using a square wave. So let's go to the selection of square wave for the wave shape. And the duty cycle is controlled by the duty cycle knob and a button called duty cycle. Notice the icon says these 4 buttons. If you have the button out, the feature is off. You push the button and it's on. So let's now bring in duty cycle, and you see that square wave. Duty cycle really means the percentage of time that the signal is high. So here we have a very low, not very much high time, and a lot of low negative time, and then we increase the duty cycle like this now. This is something like 75% duty cycle. If we go back with the duty cycle disabled, it comes up default being 50% duty cycle. Half the time it's high and half the time it's low. Finally, our last topic is DC offset, and that's controlled by a DC offset knob and an DC offset button. The concept of DC offset is simply that we add a constant voltage to the waveform of interest. So right now the DC offset is removed, it's disabled, but let's push it in. And now this DC offset knob allows me to add a constant to shift the waveform up and down by a desired amount. Again, we can go disable that feature by pushing the button back out. Well, that's the conclusion of our tutorial. I hope you engineers will enjoy using the function generator to help you increase your knowledge of math and electric circuits. Have fun.